This is Josh White with JW Math Tutoring. In today's video, I'm going to cover Bluebook PSAT 10 Practice Test Number 2, Module 2B, the harder of the two second modules. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Before I begin going through this digital PSAT 10 Practice Test Number 2, Module 2B, the harder of the two second modules, I just want to mention a couple things. First, if you like this video, of course, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, if you haven't done so already, please check out the full solutions and explanations to Module 1 from the same test, and also Module 2A, the easier of the two second modules. And lastly, this video will most likely go past the allotted 35 minutes of time that you have to complete these 22 problems. That's because on some of them I'm going to show multiple methods to solve them, possibly even 3 different ways to get the correct answer. So just keep in mind that on a normal test that you're taking, you wouldn't need to do all those different methods to solve the problem and confirm your answer. You'd only do that if you had extra time. Okay, so with all that being said, let's go ahead and get started here. Question number 1, where is this parabola intersecting the x-axis? Well, we can clearly see, intersecting the y-axis. It is at this point right here, which is 0, 7. What's the value of y? That is just 7. So we just enter 7 as our answer. What's going on here? And that's it. Next question, you're just asked to evaluate a function, so you're just going to plug in -7 for x, and that's going to be -28 minus 6, which is just -34. So the correct answer is A. Of course, you could go to Desmos and you could type the function in Desmos as it's provided. And then you could just do g of -7, and we get the same answer, -34. Next up, question number 3. This is basically, x, number of samples, minimum number of samples, plus the 63 that are already collected, and we need at least, i.e. greater than or equal to 67. Okay, so how many do we need? Well, we just need 4. X greater than or equal to 4. So the minimum number that you need is 4. And again, you don't even need to write out an inequality like this. You can probably just think of it, look at the problem and think of it and say, okay, we need 67, we have 63, just subtract them, and get the difference of 4 as the amount that we need. All right, next. Here we have a triangle. They give us the perimeter. They give us 2 of the sides. So the perimeter is 17. One side is 4, one side is 7, the other side we don't know. Let's just make that x. What does it have to equal? Well, it's just 17 equals 11 plus x. X equals 6. Therefore, correct answer for this one is just letter B. All right, next up, here we have a a linear function or a line, and we have tables of values, and we want to know which of these shows the points that correspond to this. So I would go and do this in Desmos because I think this is the quickest, fastest, easiest way to do it. Here is literally what I think is the easiest way. Type in the function, click Edit List, and then click on this Create Table. Now, if it didn't already have -1, 0, and 1 filled in here in the X column, I would type those in, but it does. So we're looking for -7, 4, and 15. Okay, the first, letter A. Do we have -7, 4, and 15? No. B, do we have -7, 4, 15? No. C, do we have -7, 4, 15? Yes, correct. That's going to be the correct answer. We can scroll down to look at D. Okay, it's obviously wrong. It's not -7, 4, 15. So that is what I think is the quickest, fastest, easiest way to do this problem. You could, though, also just graph the line here, and then you could start with answer choice A, and you could plot this point, and you could see, is the first point from the table on the line? Okay, it is not, so eliminate it. Then move on to answer choice B, -1, -4. Is that on the line? Nope, It is not. So you would eliminate it. Then if you go to C, you'd go through all three of them and you'd see that they all work. And that would be correct. And if you go to D and just check the first one, -1, -11, again, notice that point is not on the line. Therefore, that cannot be, the correct answer. So that's an alternate approach you could take, but I think it, takes a little bit more time than the first method I showed of just using the table. Next up, question 6, we are evaluating a function. So we have 4 times 21 to the negative first. Now that just is the same as moving the 21 to the denominator and making it to the positive first, which means we just get 4 over 21. Correct answer is C. Now, if you went to Desmos and you typed it in like this, okay, and then you said f of 21. Notice it gives you some random fraction, right? But if I just click the circle here, then it converts it, or excuse me, it gives you a random decimal, and then you click the button to convert it to its appropriate fraction, and then you get 4 over 21, which you see as answer choice C. All right, next up, question number 7. Here you have a graph, the population in a town, and it wants to know basically which of these answer choices best describes what happened from 0, x equals 0 to x equals 1. So basically this part right here, okay? We're basically looking at like this section of the graph. Okay, so notice it's at 6, technically 6,000, when x is 0, and it's at 9, technically 9,000, when x is equal to 1. All right, so all of these start the same. They all say the estimated population x equals 1 and then is blank times the population at 0. So the answer to this question is like the population at 1, which is 9, is equal to what times the population at 0, which is 6. In other words, 9 is equal to what times 6. So you could just, solve this out. It's just 9 over 6. It's just 1.5. The correct answer is going to be letter B because 9, or 9,000, is 1.5 times the population at 0, which is 6,000. Next up, we have a scatter plot and a line of best fit. For how many of these points does the line of best fit predict a greater y value than actual? So right here, line of best fit greater than actual. That means how many points are there on the graph which are below the line? 1, 2, 3, 4, 5, 6. Because at each of these x values, the predicted value from the line of best fit is higher than it. See, be up here, be up here, be right here, right here, right here. Okay? So the correct answer to this problem is just 6. Next up, we have a system of equations. What's the solution to this? I'm just going to go to Desmos because we have these. You could set them equal to each other and technically use substitution, but because we have these fractions, it can kind of be a pain to solve. So I am just going to type them out, see where they intersect, and we want the x value right here. Okay, so where do they intersect? 24, -6. The x value is 24. That's it. Don't need to do any more work. All right, here we have a word problem with a linear function, i.e. a line, and technically they're giving you 2 points here, okay? X is the number of items, so the first point is technically 8, 220, and the second point is going to be 10, 320. What's the equation of the line that goes between those 2 points? So it's just 320 minus 220 over 10 minus 8 for our slope. 2 on the bottom, 100 on the top. Slope is equal to 50. Okay, right off the bat, it is one of these two. It's actually probably not going to be C because notice here, this says 50x minus 10x, which is really equal to 40x, and therefore the slope of this line, C, is not equal to 50, the slope of our line. So therefore, we could get rid of that. We already know the correct answer here is going to be letter D. But let's see how you could solve this in Desmos. So we'll just make a table. We will do the 2 points. And then I'm going to type the regression statement, but you could also use the regression button. Slope is 50, y-intercept negative 180. 50x minus 180. So that's the correct answer. Again, you could also click this. Linear is the default. Y equals 50x minus 180. There's our answer. Move on to the next question. All right, number 11. If this equation has infinite number of solutions, what does the value of a have to be? So basically, what's going on here is, excuse me, you want the x terms to have the same coefficients. So if I distribute this on the right, okay, notice I get ax plus 3a over 2. Now I'm going to multiply by 2, both sides, to turn this into 8x plus 24 equals ax plus 3a. Okay, for this equation to have an infinite number of solutions, essentially what you're going to do is set these two equal to each other and technically set these two equal to each other. They both have to be equal, and you can clearly see now that a has to be 8. 8x equals ax, a must equal 8. 24 equals 3a, again, a has to be 8. So the correct answer for this is just a equals 8. Now, here's an alternate approach that you could use in Desmos if you didn't know that or didn't, remember to do that. Graph both of the lines. Do the division sign first here. Okay, so I'm graphing the left side and the right side, okay? Then I'm going to add a slider for A. I'm going to plug in the different answer choices. And what I'm looking for is, with infinite solutions, the same line over top of itself. So 0, it's not the same line. There's one solution. 3, not the same line. There's one solution. 8, notice it's the same line. I turn this off, I see the blue one directly underneath it, and there's only one line on the graph. That's an alternate approach you could take on this problem, since it is a multiple choice question. Next up, we have a basic percentage problem. So what's going on here is this price in April, which is $17.36, was P% of the price in March. So P% of the March price, which is $15.50. So this is just the basic equation that you're solving. You essentially just divide by 1550. And then you're going, really, so this is an equation. It really would just be P. And then you would get a number, which should be, let me just look at my notes here, 1.12. And then to convert that to a percentage, you just have to multiply by 100%. So it's just going to be 112%. Now, just to show you in Desmos, you can actually do it in one step where you can do 1736, and I'm going to use regression because I want to use P% of 1550. And right there, because I put the percentage in, my answer for P is the final answer to the problem, the 112. And that's it. That's literally all you have to type in Desmos. You get the answer in 10 seconds. All right, next up, we have another system of equations. I would not bother solving this by hand. I mean, technically, you could get the bottom one equal to y equals, set the bottom one to y equals 8x plus 16, and then you could substitute that into the first one, and then you could go ahead and factor it. But why do we want to spend all the time, doing all that work? Let's just graph both of these and see where they intersect. All right, so it looks like it's right here. Yep, clickable point, -4, -16. So correct answer to this is letter B, and that's it. You don't need to do any more work than that. Next up, we have a formula. So first I'll show you how to do this by hand, and then I will show you how to do this in Desmos. So we want to solve this for a. Okay, technically, easiest thing to do is actually to divide both sides by the entire expression b plus 9. So you get x over b plus 9 equals 8a. And then, I mean, I could actually have done this in the first step, but I'm going to divide by 8. So I'm going to put the 8 out here. And that's it. A equals x over, and the denominator, 8 parentheses b plus 9. So it looks like the answer choice to this one is letter B. But let's see how you could solve this in Desmos. Now, if you wanted more information about how to solve any formula by hand in Desmos, check out the thumbnail for the video from my Ultimate Desmos Guide to Digital SAT Math that's listed on the screen. It should be from Part 5, Advanced Functions, but the video on the screen, the thumbnail on the screen shows you which specific video it is from. So I'm going to type this. I'm going to use regression. And then, now, because I have an x here, I technically have to make this x1. Okay, it picked values for x and a and b, and it made them all positive, which is a requirement of the problem right here. The positive numbers, a, b, and x. So that's good. So now I just type the answer choices, and I got to use x1, and I see which of these answer choices is equal to the value of a that the regression chose, which is 0.0125. All right, answer choice A, obviously not it. Notice answer choice B, yes, this is it. This does match. Let's just check C, just to make sure it's wrong. Yep, does not match. And now, of course, D, yep, does not match. Okay, so this just confirms it's answer choice B. That's how you could solve this formula question. All right, next up, we have two functions that are being multiplied, and it wants to know which of these is equivalent to this. So technically, what you're doing, right, is you're multiplying this by this, and you're doing FOIL, first, outer, inner, last. Two eyebrows and the nose and mouth. That's the way I like to think of it. Okay, except you got all these nasty fractions, so instead of spending the time doing that, I'm going to go to Desmos. I'm going to type in the two functions. H of x, 6x minus 5. Okay, then I'm going to multiply them. All right, now get rid of this, get rid of this. So I've got a quadratic, right? Now all I have to do is go through the answer choices and see which one overlaps the green graph, the green parabola, entirely. Okay, it is not A, so we can eliminate that one. So let's check B now. 27x over 11. That does not overlap entirely. Let me just get rid of this so we can see the full graph clearly. So let's now check C. We only have to change, edit basically one of the terms. That does not overlap entirely. It looks like it's shifted to the side, but it's pretty similar. And let's check D. Now here we have it. Notice I unhighlight this, and I see the green one directly underneath it. So that tells me D is the correct answer. That's how you could solve this entire problem in Desmos. All right, next up, we have a word problem. So basically, the problem is going to set up like this. You have these two positive integers, x times y, let's say, being multiplied to equal 462. The first integer, x, we'll say, is 5 greater than twice the second integer. What is the smaller of the two integers? So you just take this, we plug it in for x, so you get an equation that looks like this. Erase this 1 second. 5 plus 2y. Okay, and now you have a quadratic equation. So you could go ahead and you could multiply this all out, distributive property, and then I just switch the terms, then I subtract 462 and get a 0. You could try to factor this, but there's no need to do that. Let's just go to Desmos and just get the answer. And I'm just going to switch to x instead of y. So that way I can look for the x-intercepts. Okay, I don't see anything here, so let's just zoom out. Okay, so here are my two possible answers, right? Notice negative 16.5, not a possible solution. First of all, it's not positive. Second of all, it's not an integer. So when I solve this, for y, my only possible integer or solution is 14. That's going to be the answer to the problem because x would be equal to the other number. In other words, would be equal to 5 plus 2 times 14. 2 times 14 is 28. 28 plus 5 is 33. So the two integers that multiply together, right, are 14 and 33. But the smaller one is 14. So that's the answer that I would submit. All right, next up, question number 17. So here you have this polynomial, technically third degree. And the graph of this function is going to be shifted up 6 units to make a new function. And this new function crosses through the point 4 comma b. What's the value of b? So if you actually want to do this by hand, what you would do is you just take this original thing and you would just basically add a 6 here at the end. And then you would take 4 and plug it in and evaluate it. So it's like 4 minus 1. So in other words, g of 4 would be equal to 4 minus 1, which is 3, 4 plus 3, which is 7, 4 minus 2, which is 2, and then plus 6. 21 times 2, 42, plus 6. And the correct answer should be 48. But you can also, again, do this entire problem in Desmos. So step 1, type in the original function. Step 2, type in the translated function, which is the original function shifted up 6 units, so we put a plus 6 outside the parentheses. Just make sure we can see the whole thing. Okay, step 3, g of 4. What is it equal to? 48. There's our answer. Took me about 30 seconds just to, type everything in. Next up, here we have basically it's like a kind of a rate slash proportion question, because you have distance and times and speeds and everything. So okay, we have two objects r and s. Okay, the speed of r is half the speed of s. So okay, let's start with r. Distance of 4x inches in y seconds. So 4x inches in y seconds. This is basically its rate, okay? Because this is like a distance over a time. Okay, so now if we want to find the speed or the rate of object s, they tell us up here in the problem, the speed of object r is half the speed of object s. An alternate way, so in other words, r equals 1/2 s. Another way to think about this is to rearrange it and multiply both sides by 2 and to get that the speed of s is equal to 2 times the speed of r. Therefore, the speed of s would be 8x over y. Okay? Just take this speed and multiply it by 2. So now that we have that, now we want to find the time it takes for this object s to travel a distance of 24x inches. So think back to the equation, rate times time equals distance. We want to know the time. So we're going to plug in the distance, which is 24x, and we're going to divide it by the rate, which is 8x over y. And now, notice what's going to happen. The x's are going to cancel out. This is going to cancel out, leave a 3 on top. This y technically will go to the numerator. I mean, notice none of them are fractions, right? It's all something in terms of y. Therefore, the correct answer is going to be letter B, 3y. Now, I will say, if you wanted to, you could pick numbers for x and y, and then you could do the whole calculation in terms of numbers instead of expressions. And what would happen is, what you would do is you would go through and you would calculate this time, but instead of like whatever you pick for x, you pick something for x and y. And then you plug those in, and you're going to get a time that's an actual numerical value, and then you plug in the value for y in each of these answer choices, and you see which one equals the same value that you got when you calculated it, initially over here. It just makes the calculations a little bit easier or simpler to understand if you're working it out. So here, I'll just show you what I mean real quick. Let me just minimize this. I'm just going to let x equal 1, okay, and y equal 1. So in other words, object R travels at a speed of 4 inches per second. Therefore, object S, again, x is 1, y is 1, is at a thing of 8 inches per second. Okay? Which expression represents the time, blah, 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 to travel now 24, x is 1, so 24 inches. So now you're basically saying, okay, 24 inches divided by 8 inches per second. Inches cancels out. 24 divided by 8 is 3. Seconds will go to the top. So the total time in this picking numbers example is 3 seconds. So now you plug in 1 for y, and you see 12, 3, 16, 6. Okay, 3 is the one that matches what you found when you worked it out by hand. Therefore, it's the correct answer. So that's just an alternate approach you could take, because it's a little easier to think about it in terms of numbers rather than necessarily working out expressions with x's and y's. All right, next question. This one, you are given a quadratic expression and told that this thing is a factor of it. What does the value of n have to be? Okay, so the theoretical way to do this is to notice that if you rearrange this and you put the k squared term first and the x squared term second, and you want k minus x to be a factor, notice there's no like middle term here. There's no like kx term here. It's just k squared and x squared. That means it has to factor as a difference of squares, meaning the k minus x has to have another factor associated with it of k plus x. So to factor this into a difference of squares like this, in front of the k, this whole thing has to equal 1. 1/29 times n must equal 1 to make it just k squared minus x squared. So what does n have to equal? Well, just multiply by 29 on both sides, and there's your answer. n has to equal 29. Correct answer is going to be letter D. Now, here's how you could actually solve this one in Desmos. Type in the original expression. Okay, then we're going to type in the factor. First, we're going to add a slider for k, and we're just going to make it some positive number. You can make it 1. I'm just going to drag it to wherever. Okay. Now what I'm going to do is I'm going to put in the possible answer choices for n. And essentially, what we're looking for is that the factor and the original expression, meaning the factor is the blue, and the original expression, the quadratic, is the red, they both need to have the same x-intercept in order for k minus x to be a factor of it. So at negative 29, we do not have the same x-intercept. Negative 1/29, we do not have the same x-intercept. Positive 1/29, we do not have the same x-intercept. However, notice what happens. Now, notice we do, right here. They both go through the same exact point. Now, if I move this, notice both the graphs change, but they both continue to intersect at an x-intercept value. That's what tells me that k minus x is a factor of the overall quadratic. So that's how you could solve this problem entirely in Desmos. All right, next problem. Here we have a exponential function, and you're doing a shift on it, technically a translation of 4 units to the right, and it wants to know which of these defines h. So I'll just talk about the theory for this real quickly, and then I'll show you how you could do this in Desmos. Basically, what's going on here, right, is you plug in x minus 4 for x, and then what happens, let me just look at make sure I write this out correctly. This 2 to the x minus 4 gets split up as 2 to the x over 2 to the fourth, because when you're dividing, you subtract your exponents. And then this 2 to the fourth, which would be 16, ends up dividing by 272 to make 17 out front, and you get 17 times 2 to the x. So the correct answer for this one's letter A. But let's see how you could quickly and easily do this in Desmos by just matching equivalent expressions. So first, we've got our original function. Next, we have our translated function. Okay, let's get rid of the original. Now, all we're going to do is just type the answer choices and see which one overlaps it completely. Okay, it looks like it is this one. And notice if I type the rest of them, no, it does not overlap. No, that does not overlap. Nope, that does not overlap. Get rid of those. But these two do. So this just confirms the correct answer choice is letter A. All right, next up, we have kind of a tricky question here with a pentagon. And so basically what's happening is you have two sides that are parallel. Say here AB, and you have to draw it like this, where this is D and this is E. Then we have angle C here. Okay, and then this connecting these. All right, we know this is 174. We know this is 139. That's all they give us. What's the measure of angle C? All right, there are technically two different ways you could figure this out. I will show you both methods. The way I originally did it is I know that for a pentagon, because that's 5 sides. Get rid of this. The total number of degrees for all of the interior angles is, for any polygon, is convex polygon, 5 minus 2, n minus 2 times 180, or in this case, 5 minus 2, i.e. 3 times 180, which is 540. Because AB and DE are parallel, angles A and E right here will be same side interior angles, which means they are supplementary. They add up to 180 degrees. No idea what that line was. So we basically have 139 plus 174 plus 180 for these two, plus angle C has to equal 540. So we just subtract everything and get our answer right from that. So minus 180, minus 174, minus 139. Okay, we get 47, which is the correct answer to the problem. All right, so that's one way to do it. Now, here's an alternate approach that you could use. If you take, if you draw kind of a third parallel line here through point C, so this is parallel to this, and this is parallel to both of them. Okay, what's going on now is you have this angle and this angle are the same. And then this angle, extending this, and this angle are the same. Okay, that's because these are alternate interior angles. Okay, both pairs, the top and the bottom. This angle right here is just 180 minus 174, or 6. So this is also 6. This angle up here is 180 minus 139, because again, it's two adjacent angles that form a straight line, basically a linear pair. They're supplementary. And so therefore this is 41. So this is 41, and then you can just add 41 plus 6 and get 47. Technically, you don't even need to worry about this or like they add up to 540. You don't have to worry about any of that if you want to take this approach and do it this way, which is also fine, because of course you get the same correct answer. All right, last question, number 22. So I will show you multiple ways to do this. First, if you wanted to do this by hand, what you're going to do is square both sides and get k minus x equals 58 minus x quantity squared. And then you're going to multiply that out, and you're going to get x squared minus 116x plus 3364 on the right equals k minus x. And then if I bring everything over to the right, I get x squared minus 117x plus 3364 minus k. Let me just look at my notes. Wait, no, that's not right. Should be minus 115. You have to add the x on the left, so this should be minus 115. Okay, now, it has exactly one real solution. That means the discriminant, the b squared minus 4ac from the quadratic formula, is equal to 0. So all I would do now is I would go to Desmos, and I'd type in uh, b squared minus 4 times a times c. C is the whole expression, 3364 minus k. This has to equal 0. Because I'm using k, I'm going to use regression. Okay, so I get my k, that's my k value for exactly one real solution. What's the value of 4k? Well, it's right there, it's 231, and that is the final correct answer. All right, however, there are much faster, quicker, easier ways to do this problem entirely in Desmos. So let's see how you would do them. Here is the quickest, fastest, easiest way. And this will work for any type of problem where it's asking for like exactly one real solution. I mean, you wouldn't really want to bother doing this for just a basic linear function, but anything with a quadratic or a radical or whatever, we can use this approach. I'm going to type in both my functions. One of them is the left side set equal to f of x, the right side equal to g of x. Okay, then I'm going to type in the following. And before I do this, if you want to learn more about this approach, and specifically this approach is typically used with quadratics. This is not a quadratic as given, it's a radical function, but if you want to learn more about how to use this, I will put some thumbnails up on the screen from my Ultimate Desmos Guide to Digital SAT Math about where I cover and go over this approach. Okay, so now what I'm going to type is f of x1, and you have to use x1s inside this regression statement. Then I'm going to do f prime of x1, so it's f apostrophe and then x1 inside there. Then I'm going to do tilde, and then I'm going to do g of x1, comma, g prime of x1. Notice it gave me the exact same k value of 57.75 that I found using the first method with the discriminant. So now, what's 4k? It's 231. Same exact answer, but I didn't have to do any work at all. Just briefly, what this approach is doing is it's basically saying where is the value of the function where do both functions have the same value? That's what the f of x and the g of x equaling f of x1, g of x1, and where are the derivatives of both functions equal? That's what the primes represent, the derivative of f, the derivative of g, meaning where do they both have the same tangent line slope? If you haven't taken calculus, then you have probably never heard of a derivative, and that's fine. You don't need to understand the theory behind it. You just have to know, that it works. So this is an alternate approach you can do in Desmos, and it is, again, finds us the correct answer, 231. Now, last thing I will say, on this problem, there's actually a trick such that the answer to this problem will always, for the 4k thing, it will always be equal to 4n minus 1, where n is whatever the number is that's like subtracted, that's in front of the x being subtracted from it. So in other words, here, I can actually look at this and know that the answer is going to be 4 times 58 minus 1. 231. And it's always going to work out like that. Like, in other words, if I just change this to 19, the correct answer for 4k is going to be 75. Don't worry about why that happens. I mean, in one of the examples for this, one of the alternate solution videos, I went through and I showed mathematically why that actually happens, why it works out like that. That's only applicable to this specific problem. I mean, this exact same type of problem if you'd happen to see it or get it. But the second method, The derivative method, that is an approach that you can use on lots of, types of problems, on quadratics and, so on and so forth. So just be aware there is a trick to this. It's just 4 times whatever this number is on the right minus 1. That's your answer for your 4K value. All right. I hope you enjoyed the solutions to this digital PSAT 10 practice test number 2, module 2B. If you did, please give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments or alternate solution methods, please leave them in the comments section below. Also, if you haven't done so, check out the solutions to Module 1 from the same test, and also Module 2A, the easier of the 2-second modules. And lastly, if you are looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It has over 6 hours of tips and tricks and instruction and 65 practice problems to help you ace the digital PSAT and SAT math sections.